Welcome to Next in Tech, an S&P Global Market Intelligence podcast where the world of emerging tech lives. I'm your host, Eric Hanselman, Chief Analyst for the 451 research arm of S&P Global Market Intelligence. And today we're going to be discussing robots with returning guest Ian Hughes. Ian, welcome back to the podcast.
Thank you. Glad to be here and another fantastic subject to talk about.
Well, and an extension of something we talked about a while back, and something that I think we'd taken a marker to think about this in more detail. We've talked about various aspects of automation and digitization. When we start making that next step, when you utter the word robot, it conjures up all sorts of images because we've invoked the idea of robots in so many different ways, in so many different spheres, in so many different genres. There's just a lot that's wrapped up around robots. So I guess maybe the thing to start off with is defining robots in their various forms and really sort of scoping what we're going to talk about specifically. And I guess overall, how should we be thinking about robots?
Well, as you say, it's something that's got all kinds of flavor of science fiction and of social change and industrial revolution, and all those things kind of get wrapped up in what robots might be. And a while back, when I was doing some work and about robots particularly, I realized that needs to be clarified because otherwise people don't know what kind of robot you're talking about. And in particular, from the IoT instrumentation side of things, a lot of the robots that we were coming into contact with in briefings and at events were really just the more standard industrial robot. And these are the robot arms that you see in factories. Every time you see a car factory, you'll see some welding arms moving around and stuff like that. Great big long rows of them.
Well, and invariably, it's all of the sparks that get generated by welding robots and arms swinging in either high speed, slow speed. Yeah,
they're very, very dramatic, and they're usually very big. I mean, they are huge things because obviously they're working on cars and lorries and things. But those robots have been around for quite a long while now. And they are really they're still very clever pieces of engineering, but they are highly maneuverable arms. They don't necessarily know where they are or what they're doing. They are just completely following the code that's been expressed to them as to what they do. So they are computer numerically controlled machinery, the same as not old-fashioned, but a lathe might be. And so I kind of started there on a classification system of saying, this is a level 0. I've got these 9 levels of autonomous robots. The level 0 is just a robot arm. It's the original industrial robot, and it's kind of standalone. It might be in a factory, but it doesn't really know what the other robots are doing. It's got no relationship to them.
Right. Not working in coordination. It is simply a vehicle into and of itself.
It is, and quite often these robots have to work away from people, so they're often placed in cages or areas that have separate sensors that cause the robot to stop if somebody wanders into that area, because they only will do what they've been told to do, and they're very dangerous in that respect because they're big heavy bits of machinery wandering around or moving around. But also, I kind of, when I looked at this again, I realised that those arms can be augmented now with richer edge computing, the same as the rest of industrial IoT has put richer machine learning models onto standard automated machinery. So we've kind of got these level 0 and level 0.5 robots that it's the same stuff, but it's being told maybe it's being given more sensor information or something else is making a decision for it. But it's brownfield updating of those traditional dumb robots, for want of a better word. But then we start getting into the levels of these kind of pieces of equipment being able to do more things. And so the next level I came up with was remote controlled robots. So this is for drones. So we're kind of at level 1 now. So people fly drones. Drones have some degree of autonomy on board, but not really very much usually. And these things are it's the human that's doing the work, but it's then the clever engineering that's transmitting their actions to that robot. And whether it's flying a drone or whether it's driving a little car around or something like that to sort something out. But then that then moves into the next layer, which is slightly richer assistive human attached tooling, as I've called it. And this is taking the engineering and placing it on the person. So exoframes are a good example of that.
We've seen those sorts of things with ideas around warehouse workers or construction workers being able to lift, heavy things far beyond what would be human-only capacity.
That's correct. And so they take the input from the person's movement, but they amplify what you can do or make things more comfortable to operate. And so sometimes they're just purely mechanical, but sometimes they have compute on board so that they can make the exoframe can make decisions about how much effort to put in. And so they're kind of our lower class of or sets of lower class of robotics. But then we get into semi-autonomous robots, like automatic guided vehicles in warehouses that move product from A to B, but typically follow a line. They have a track that they follow. They're not making a decision or being able to go anywhere in the warehouse. And that's the same sort of autonomous or semi-autonomous stance that you get from a robot vacuum cleaner or from a robot lawnmower. They're not actually making a decision to find the best bit of grass to cut. They're bouncing around almost not quite randomly, but they're doing a patrol pattern, and they're restricted by guide wires that let it know to stop at the edges.
Either something that's sensed or something where they've built an internal map or something in which they've got a set of constructs that are going to constrain where they go.
That's correct. And I mean, most of them are a guide wire you insert into for lawnmowers anyway, that you insert into the lawn. And so you are starting to see ones that are trying to use things like GPS or sense the things around them, but GPS isn't actually accurate enough to stop the lawnmower going in your pond. Because of so it needs lots more sensors.
An error in lawn, plus or minus a few feet or a meter or two here and there could have dramatic consequences for your garden or any other aspects of.
And so you can see that, but the fact that it's called a robot and the fact that it's doing a job and it's wandering around, then people might stick some googly eyes on it and think it's somehow sentient or more of got more autonomy than. Because it appears to be magical in the things that these do. But then we've still got a long way to go up this stack, because we're only now at kind of what I called level 3. So level 4 is for mesh and swarm robots. So these are robots that bother to cooperate with one another. So typically, you see these in factory situations where they have to stop and start as there's hundreds of them scooting around, moving products, lifting things, but they have to deal with the particular situation that's directly in front of them, or have an overarching control to say you need to stop, you need to start. So it's like a traffic control system, but there's a lot of robot to robot communication because that's the most efficient way to do it. So it becomes a sort of swarm of those. Again, they look very efficient, and they are very efficient, but they're not intelligent in any way. And then that takes it. So we're still in automation that's doing a job and kind of saving us the hassle for people having to do it. But then we get to level 5, which is where it really starts to get very interesting, I think, because this is where I've kind of placed collaborative robotics or cobots. And these are a class of robotics that is designed to work with people. So it's typically to perform some roles on a factory floor or wherever it happens to be. But the aim of this robot is to understand or quickly be shown the job it needs to do by the person that's going to work with it, not be some kind of high-end bit of programming that needs to be done, or grab the IT department and say, can you sort it out? So you demonstrate to a robot what to do. It will then do the job with you. So it's, can you pick this up? Can you hold this for me? while I assemble this. And the aim is to be able to do lots of different types of jobs very quickly. And some of these cobots, I mean, they've obviously got lots of sensors on so as not to bump into people, not harm them, and as opposed to the industrial robots we mentioned before. But there's a lot more onboard sensors and vision systems and things that need to be in place for these things to work.
When it sounds like that's really a situation in which we've got the ability, it's the sensors are allowing that collaboration, are getting to that next stage, and robots are set up with a flexibility to be able to be a little bit more abstract in their interactions.
That's correct. And the more basic of cobot is just going to do the same thing as the industrial robot does. It's just it's smaller and easier to tell it to do it. But as these things improve and you start, and we certainly see them at trade shows and things, you start to see robots that you can tell it, I would like you to pick up the square thing. You know, that's its job, to pick up the square
levels
thing.
Levels of understanding that let it take direction, but that require it to actually have a certain amount of capability for identification, some level of presumably vision integration,
yes.
A set of things that take it to that next level.
Yes, and it's that adjusting. So if something's a couple of millimeters out, or, I mean, typically the use case is picking things out of a bin where you need to get the thing orientated correctly, but there's loads of them chucked in a bin because you're assembling some products. And so the aim is to pick the thing up from the bin, which could be anywhere in the bin. It's on the top layer, obviously, but anywhere in the bin. The robot's picking it up, but picking it up in the right way to give it to you. And each time it has to make that adjustment. And so there's a lot of processing potentially in that, but it's the making it useful and getting rid of the repetitive piece that the human maybe could do, but why should they if you can get a robot to do it?
Well, and the human then gets to do the thing that's the useful human thing, which is fine positioning, orientation in a complex environment, doing things that it would be much more complicated for a robot to do effectively. And now you've offloaded the sort of the simple task of finding the bit and actually getting it to them.
And there's examples. One of the companies has a table tennis table that each year gets upgraded at any of the shows, and so the cobot is there to play table tennis. Now that's not obviously a general business case that you might think works, but the ability for it to adjust how it returns a ball, because it can see the ball, it can get the bat to the ball as quickly as possible, and it can decide where it's going to direct it. It could win every time because it's got superiority over what a person might be able to do. But the software is adjusting to the ability of the person to push them a little bit further. So it doesn't just throw them easy balls back. It will gradually ramp up until they can't deal with it, and then it'll ramp down again. And so that form of adaptation, whether it's in physical robotics or whether it's in kind of general software that you're working with, so it tries to understand and adapt. That's the kind of useful side of the AI industry that's often embedded and hidden in things that we don't always realize how clever that stuff's being to try and help us. I mean, you can see it in word processors, how you might suggest a change to wording to make something more readable.
Well, but the adaptive part, I think, is the interesting aspect that differentiates it, which is simple correction is pretty straightforward, but being able to understand, I guess Eric missed that one, so I guess we'll not serve it with quite as much spin next time. We'll bring it down a notch, but then continue to sort of push up, especially in things like training, where that understanding and that adaptivity has to come into play in order for it to be that level of useful in a training environment.
Correct. And as humans, we do get bored with repetition, don't we? And so, but if there's slight changes, or we are gaining better skills, we're getting a bit quicker, we're finding a different way of doing something, all those things kind of keep our brains going and make anything interesting if there's a twist to it. And so that's say cobots fit in this. I mean, it's a huge, great subject in its own right, but they sit in the middle of what autonomous robots are in this list, because the next stage, which is level 6, is for fully autonomous vehicles. And we see a lot about self-driving cars, and that there's SAE have their 5 levels of autonomy in just vehicles, and level 5 is the top one. It's a fully self-driving car that doesn't need a steering wheel to take you wherever it needs to go, and we haven't quite got there yet. But if you notice, we're kind of at level 6 in our list of autonomous robots, because there's a lot more to go past being able to do a self-driving car, and we haven't quite got fully self-driving cars yet. So there's lots of emerging technology that sits on top of this. But clearly, an autonomous vehicle able to navigate from A to B and take anything or anyone there and back again safely is an autonomous robot. I mean, that's people often don't call their cars a robot, but when it's doing that,
right, but functionally they're doing, they are an automated instance with a whole set of characteristics which clearly make them robots.
Yes. And so then after this level 6 said that there are things in the 7, 8, and 9 lists that could be pushed towards science fiction, and we have certainly seen in science fiction, but there are elements of where these things can develop that are happening, maybe not all at once with all the same people, but so we've got classified it as an autonomous free roam robot. So something that's not, I mean, a car is designed to go on a road. If the road's not there, then that's outside its machine learning model, so it's not going to know what to do. But if you're talking about sort of a disaster situation, you're trying to send a kind of 4-legged robot in, or even a bipedal robot in to look for people, it needs to and assess the situation. It needs to build a model of the world and be able to deal with almost anything, just as humans would.
Well, and to do that dynamically in ways that your typical autonomous vehicle doesn't. It's being able to encounter situations for which you don't have a map.
That's right. And so there's the moving through terrain, whether it's, wet or boggy or rocky or up or down, or it's buildings with doors and stairs and things, all these things that we kind of take for granted. There's a level of how does any kind of device manage to get through those things? So that's one of the big tasks, is to be able to get to a point where you can just say, go over there, and it will just sort it out. And that's only level 7. So level 8 is that, but being able to do lots of completely different jobs while it's in that space. So you said you might have at level 7, you might have some sort of rescue robot or one to put out a fire or something like that. That's its job. But with people, for instance, we tend to say, can you go and do that job over there? And they may never have done it before. So they'll take a screwdriver and undo a screw, or they'll weld something, or they'll glue something. And we're not at that point yet. We can put different things on robots to make them, to give them a different payload potentially, but not to say a lot of robots are single task ones, because it's easier for us to build those at the moment. And then we kind of then finally get to the 9 and above, because I'm sure there's some after this, but which is to be that autonomous free roam multi-role robot, but one that works with everyone else as well. The mesh and swarm elements of being able to communicate, and robot to robot and robot to human. So that's almost, I mean, we like to think of robots as something like people, but that is a person, effectively.
Well, but it's that aspect of being able to take that next step of the, hey, would 2 of you come over here and help me lift up this thing kind of coordinated effort that, the mesh capabilities really start to bring to the fore.
And of course, these don't have to be the human-shaped robot necessarily. And you see across social media and things, there's lots of images of very advanced robotics, where the robot's on 2 legs and dancing or jumping or somersaulting, and they're able to move around environments. Or there's the 4-legged ones that look like a giant dog. They don't all have to necessarily have those kind of mechanisms. They're very clever and they're important, but it might just need wheels, or it might need to just fly somewhere. So, or as is represented across all of robotics, effectively, there are robot mechanisms that are based on other traits in the physical world, or particularly in the animal world. So the way wings might work or the way snakes slither and things like that. So there's lots of other ways to get things to move around and potentially then do their task without it necessarily having to be a 6-foot silver glowing-eyed dangerous robot.
That's come back from the future with a message.
Absolutely. And that's, as I said, that's what will conjure up in people's minds when they see robot.
Well, again, because there is so much of that's been presented in such significant and impactful ways throughout movies, science fiction, and all the rest. There's a tendency to jump to those expectations. But to your point, there are a lot of different forms that robots can come in. I mean, even we talk about things like pipeline inspection and plumbing and sewage systems. These are all environments in which you've got something that moves in ways that are very non-animal like. Well, at least non-mammal like, shall we say?
And again, the kind of spread of where the autonomy is and where the levels of intelligence, I'll use that word very delicately, but levels of clever code and clever tech live, is fully spread across all these kind of devices, because you've got things about a device maybe being able to keep its balance. So if you've got a bipedal robot, how does it not fall over? If it takes a step, how does it make sure that it can move and not keel? We have a balance system in our own brains that we don't think is intelligent. It just keeps us vertical when we need to, doesn't it? And those kind of internal systems that are managing all the various servos or all the hydraulics, all the normal things that you might think of in a body. Some of those are using highly complex pieces of code, and others are just using a simple sort of tilt switch sensor to say, well, you've fallen over, stand up. But that then is separate from the kind of wider AI conversation about the thing that's then deciding what this robot should be doing. And whether it's on board or whether it's an external piece of compute that's doing it, that's where the over and above autonomy, that then becomes the self-direction or the cleverness of it or the intelligence of these robots. And most things don't have that because we've not got to that stage yet. So you build a robot, as I said, to do a particular task, whether it's cleaning windows or burrowing or putting a fire out or spotting or doing a security patrol. It will know if there's movement or if there's something in the wrong place, and it'll maybe take a picture of it, but it's not then suddenly going to turn into an arrest robot and go and capture somebody and cuff them. That's not what they're geared up for. So it's sort of singular tasks, not just necessarily one, but a singular main job for that robot to do, even if on board it's got tens of thousands of processors kind of running to try and keep it doing those things. So there's a wide spectrum of technology challenges in all of that.
Well, and we start looking at multiple functions, keeping all of these things aligned enough, integrating them, coordinating them. I mean, that is a whole challenge into and of itself, which, again, to your point, is why we head towards focused function capabilities today. And we've talked a little bit about some of the autonomy pieces. I guess I'm curious about when we start getting into these greater levels of sophistication, and we think about what we've done just in the progression of sophistication in IoT generally, that we start getting into questions about simulation and interaction, and getting back to the great conceptual thing that we've dealt with in both IT and OT spaces, which are digital twins. Starting to think about some of the simulation aspects of how do we understand the world? How, to that point, do the robots start to interact with the world, and things that we can start to explore in simulated environments. But digital twins have got a significant role to play in robotics as well, yes?
They certainly do. There's, again, digital twins kind of are very multi-layer in how you can consider them. So the robot itself, whatever type of robot it is, the robot itself has a bunch of instrumentation, and particularly if it's mobile, there's a where is it in the world and things like that. It ends up effectively having a digital twin somewhere of its status and what's going on. Even if you have a kind of a toy robot from a crowdsourcing project, you'll have an app that will have a picture of the robot and what the various servos on it are doing and things like that. So on an app, so you end up with that digital twin of it, because it's a complex collection of automation and IoT sensors and software running, doing all sorts of wonderful stuff. But the other part of it is when you're dealing with a highly, or trying to create a very autonomous robot, it needs to be trained. All AI and ML methods need to be trained somehow. So if you're in a factory and do predictive maintenance, you take all the data from the production line and feed it into the big mass of machine learning that you have to try and get a machine learning model that you then drop on the shop floor to help you run the machines better. Now with robots, and we'll maybe stick to ones that move around, because that helps this work better for people. If a robot needs to work out how to get from A to B, and it's going to be different every time, or there might be different obstructions, or weather might change, for instance, when you're dealing with autonomous vehicles, or lighting might change, all those things can be simulated in a world. And whether we call it a metaverse or a digital twin of a world or whatever, it's effectively you're taking a digital version of the robot and its brain, if you like, and you're dropping it in a simulated environment that's as close to the environment it's going to have to work in as possible, or the variants of that environment. And then you can then run hundreds, thousands, millions of different simulated instances of what might happen to that, where things might fall over, where things might change. Let's say every lighting condition, every heating condition, all those things, people wandering backwards and forwards in it. And that will build that machine learning model, which you then deploy on the physical robot. And so there's the robot's AI effectively doesn't know whether it's in a digital world or a physical one, because it's the same thing as far as from its perspective. And so you can use, the richer the simulation environment, the more permutations you can do and the better the model can get. And so we certainly see, whilst they do have, they've been training self-driving cars by driving around on roads with people, and you have a much bigger computer in the back of the car to try and capture all the data and work out what to do. They are also being trained in virtual worlds that look the same as a city, and down to the right colour traffic lights, and the painted lines are in the right place, and the shadows on the road, and all those things that might otherwise complicate things that are done within that digital twin, or within that metaverse application.
You've said the metaverse word. Well, even taking this back to a relatively simple case, the robot vacuum cleaner. And here you still have something that has to be able to figure out, was that door closed? Am I going up and over the rug? Which rooms have I cleaned already? That's really helping it build a realm in which it's operating that is a form of metaverse.
It can be, and that's one of the things with things such as augmented reality headsets and things like that. We've kind of touched on those before, but they have to understand, and this is things people are wearing, they have to understand the world around them. So they build a point cloud model of everything that's in front of it, and it will remember that there's a wall, or not necessarily remember, the model has a wall in it, so that, or there's a door, or there's open or closed, those kind of things, so that when it's projecting the digital content for the viewer, it will be in context with the physical world around it. Now, those models have typically only been just for that one application and that one headset, but they're starting to become a shared model, because if more than one person is wearing a headset wandering around a factory to do repair work, for instance, you can also map the factory. So you can create the digital model of the floor plan, which you can then use to train your next robot on to wander around to fix the thing the next time. So it is all about sensing and understanding either the physical world or building one from scratch that's close enough, because you might be building a new factory and you don't have one that you can wander around yet, but you want it to be populated with these robots that can operate with one another and with the factory and the people in it. So you build a full digital twin of that factory, including digital twins of the devices that are going to be in them, and including being able to have people enter that environment virtually and wander around and work as if they would normally, to add to that training. So it balloons into a much bigger model of everything, but it's that ability to interact with it, whether it's the robot interacting with it or whether it's people interacting with it, or both.
Well, and it extends what we've talked about with digital twins, which is the ability to accelerate the development of new physical worlds, because you can do this all from a simulated perspective. But I think the thing that's fascinating about what you're identifying is that in the same way we can simulate this environment, we can start getting all of the robotic aspects used to this new environment, helping them build those capabilities. I mean, to get back to the robot vacuum, this is something where if you were building a house, you could actually have a robot vacuum that arrived knowing where to go and which rooms to vacuum and exactly how to, what the layout of the house was before the house was actually even built.
Absolutely. But again, that robot vacuum example, that the current ones, some people might think that's what they already do, whereas they bounce around knocking off the walls. If the door's open, it'll go through it.
Yeah. They're not building sophisticated models today.
No, but it can seem like it is, and said quite often, you stick googly eyes on something and people think it's a sentient robot, and you see a lot of robots, even at robot shows, where they'll put eyes on something, even if it's a robot arm, and people go, "Oh, well, it must be intelligent."
That just doesn't take much to get us to that anthropomorphizing kinds of expectation around robots.
We're very simple beings, aren't we?
Well, so what should organizations be considering in terms of thinking about the use of robots, that next stage? I mean, clearly we've already got very significant industrial adoption. What are those pieces that we should be thinking for the broader markets, maybe for those who haven't really started to work as directly with robotic capabilities?
I think it's in that area of collaborative robotics. So the whatever tools people use in whatever their role is, particularly if there's a physical element to it, such as in healthcare and stuff like that having something that helps. So it's not necessarily all about replacing people and everything they do and being lights out operation for absolutely everything on the planet. It's about using the technology to have a better way of doing the job you need to do, or alleviate the more difficult or mundane parts of it, potentially, or heavier parts of it, but still have the human side of things to be able to make the decisions and the agency to fix things or do things or move things or make the decisions that need to be made. And I think that's a more realistic reason to have robots. That there will still be full automation kind of coming, but then even if you have full automation of something, we don't necessarily have full automation of the repairing of the robots. So quite often we see companies have put robots in, but then the people that are on again the manufacturing, but if they're on the shop floor, many of those people then become retrained as robot engineers. They end up on effectively a higher grade, higher skilled job, which is necessary to keep the production line going, but is maybe more rewarding, more fulfilling as well.
Yeah, more interesting in terms of what they're, rather than the repetitive things that the robots are reasonably suited for, you now have the more sophisticated troubleshooting of, it broke, how do we fix it? All those sort of pieces that next level up.
Absolutely.
Well, there are a lot of other places that we could go with robots in general, but we are at time. Again, Ian, so many more conversations to have around some of the implications, some of the aspects. I know if you look at so you've got some research published on this, which I would point our listeners to take a look in some of the more detailed assessments of a lot of this. but a lot of next steps that also have social impact. So there is, as usual, a lot more that we can get into, and I look forward to the next time we're able to get you back on the podcast.
Thank you very much. Looking forward to it already.
Thanks, Ian. And that is it for this episode of Next in Tech. Thanks to our audience for staying with us. And thanks to our production team, including Carolyn Wright, Katerina Yakoviello, Ethan Zimmon on the marketing and events teams, and our studio lead, Kyle Cagnolosi. I hope that you'll join us for our next episode, where we'll be discussing buy now, pay later, and a lot of the activity that's going on in that realm, because there is always something next in tech.